Hi, it's Jo Karen Hudson. Today I'm going to discuss with you section 10.4, which is rationalizing the denominator. We want to explain in words what it means to rationalize the denominator. So I'm going to start with the fraction 1 over the square root of 7. The square root of 7 is an irrational number. When you rationalize the denominator, you want to replace the irrational number in the denominator, replace the irrational number in the denominator with a number that is rational. Let's start off with our first example. The irrational number in the denominator is the square root of 2. That's the irrational one in the denominator. So I want to replace that irrational number in the denominator with one that is rational. So I'm going to multiply the top of this fraction, the numerator, and the denominator by the square root of 2. And I know that 1 times the square root of 2 is the square root of 2, and that the square root of 2 times the square root of 2 is the square root of 4. So now I'll have the square root of 2 over, let's see, the square root of 4 is equal to 2, so I will have the square root of 2 over 2. Final answer. Our next example, I have 2 over the square root of 18. Now the square root of 18 is the irrational, and it will actually break down. I can use my program to break it down. If you just press enter, you can continue into the program. The square root of 18 is actually 3 square roots of 2. Square root of 18 turns into 3 square roots of 2. So now I have 2 divided by 3 square roots of 2. Now the square root of 2 is the irrational in the denominator, so I'm going to multiply the numerator and the denominator by that irrational part, the square root of 2. And that would give me 2 square roots of 2 over 3 square roots of 4. So now I have 2 square roots of 2 over 3 times, what is the square root of 4? It's 2. So I can either multiply that out or I can cancel the 2's out, and I will have the square root of 2 over 3. Final answer on that one. 6 square roots of 5 over the square root of 28. Now the square root of 28 is the irrational in the denominator. I can break that down. Just press enter. If you're in your program, just press enter and you'll stay in it. Square root of 28 is the irrational I want to break down, and it will become 2 square roots of 7. 2 square roots of 7. So now my problem will be 6 square roots of 5 over 2 square roots of 7. And the square root of 7 is the irrational part in the denominator, so I want to multiply the numerator by the square root of 7 and the denominator by the square root of 7. That will give me 6 square roots of 5 times 7, which is 35, over 2 square roots of 7 times 7, which is 49. Now, if I notice right off the bat, I can reduce that, which will give me 3 square roots of 35 over the square root of 49. 2 goes into itself once and 2 goes into 6 3 times, or 6 divided by 2 is 3. One more step is getting rid of the square root of 49, because the square root of 49 will become 3 square roots of 35 over 7. 3 square roots of 35 over 7 is the final answer. Now I want to rewrite this problem with separate radicals. The square root of 17 over the square root of 3 times the square root of 17 over the square root of 15. And I know that when I multiply the square root of 17 times the square root of 17, this is good to know that it will eventually become a 17. I think that number is 289. 17 times 17 is 289, but that's going to become 17. The denominator of this will be the square root of 45. I can actually use my program to break down the enter. square root of 45, and that becomes 3 square roots of 5 divided by 3 square roots of 5. Now the square root of 5 is the irrational part in the denominator, so I want to multiply the numerator by the square root of 5 and the denominator by the square root of 5, and then I will have 17 square roots of 5 over 3 square roots of 25, or I'll have 17 square roots of 5 over 3 times 5, because the square root of 25 is 5, or I'll have 17 square roots of 5 over 15, and that will be the final answer. A little more practice with using the CPLX root program. I want you to understand that program well because it is used again in Mod 14. If you want to use the program in Mod 14, you can. I do not have it in the videos currently, but if you learn how to use the program in Mod 10, you will be able to use it in Mod 14 as well. Let's go back and start over on the program. Press Program, cursor until you get to CPLX root. Press Enter, and enter again, and then I'm going to do the square root of 54. And the square root of 54 becomes 3 square roots of 6. Final answer there. And then I want to do the cube root of 375. Press Enter, takes you back into the program. The cube root, I'm using a 3 as the index, of 375 gives us 5 cube roots of 3. Actually, this says 5 x roots of 3, but you have to remember that the index you're using is a 3 and put the 3 back in. 5 cube roots of 3. Now on example 3, I'm going to break down the square root of 18. Square root of 18, that gives me 3 square roots of 2. And I'm going to break down the square root of 32. I'll have to keep the 3, but I'll break down the square root of 32. That gives me 4 square roots of 2, so that I have 3 square roots of 2 plus 12 square roots of 2. The like part is the square root of 2, so I'm going to add the coefficients. 3 and 12 is 15, and keep the like part, which is the square root of 2. Now, be sure that you ask your instructor to give you the CPLX root program if you want it. It saves a lot of time and effort. This has been section 10.4. You will need to do the homework on that section as well as the quiz on section 10.4. This is Jo Karen Hudson. Thank you and have a wonderful day.